Originally,
Newton defined his second law as the summation of forces is equal to the summation of the time derivative of the masses times velocity, where the mass times velocity was defined as momentum. If the summation of forces on a system is equal to 0, then the summation of the momentum should equal a constant. In this case, then the initial momentum of a system should equal the final momentum of the system if the law of conservation of momentum would be is to be observed.
In the first experiment, we tested the law of conservation of momentum in an inelastic collision. The skater skated at this constant velocity toward the center and was handed two 20-pound weights, changing his velocity.
In inelastic collision, we have a first mass, m1, going at some velocity 1. It's going to collide with some second mass, m2, which is also going at some initial velocity v2, which in this case it's equal to 0. So we have m2 v2 plus m1 v1. After the collision, we have our mass 1 plus our mass 2, m2 plus m1, and they are going at some final velocity, vf. So the final momentum is m1 plus m2 times the final velocity.
Using the program called Tracker, we were able to determine the skater velocity as a function of time. We then compared the velocity beforehand at the weight and afterward in order to calculate the percent change in momentum. As the graph shows, the percent change in velocity was slightly different, giving us an approximate conservation balance within 3% errors.
For our second experiment, we have an elastic collision between two pool balls, and we can clearly see the speed that is transferred from one to the other.
In elastic collision, we have one mass going at a initial velocity, m1 v1, that will then also add to a second mass, also going at initial velocity 2, which in this case is 0, m2 v2, will equal to the initial momentum. After the collision, we have our first mass, which will then go at some final velocity, and the second mass, which will also go at some final velocity, to get us the mass 2 times the velocity 2 final plus the initial mass, the first mass, velocity 1 final.
As in experiment 1, we use Tracker to determine the velocities of the objects being examined. In this case, a pool ball with an initial velocity strikes a second ball, transferring its momentum. Due to friction and the fact that this is not a perfectly elastic collision, the percent error was considerably higher than in experiment 1. However, the data shows the empiricism of the law.
One of the major ways that we use the conservation of linear momentum is in the study of car crashes and automobile safety. To that end, engineers use these basic equations in order to model the way that vehicles crash into each other. This allows them to understand the mechanisms behind those crashes and design cars that are able to deal with those demands. In this way, we're able to design safer cars as time goes on. A related application is the role of this conservation principle in police forensic reconstructions of auto accidents, both elastic and inelastic.